Dragon's Lair is an early 80s arcade game that used a laserdisc for video playback as part of gameplay. Players were tasked with pressing a button or moving a joystick at just the right moment to keep the playable character alive and get to the next area. The NES release arrived years after the arcade game and was quite different. With no laserdisc for the NES, it was a matter of keeping the overall theme of the game intact while using typical graphics for the system. Gameplay had a leisurely pace at times versus the arcade, but wasn't without a few frustrations. For the US release in particular, control response is sluggish. In fact, the entire game feels sluggish, like it isn't running at full speed. A year after Dragon's Lair hit the US, it arrived in Japan. Both regions used a TV signal that outputs at 60 Hz. So aside from changes to logos and language, the game should otherwise behave the same. Nevertheless, the gameplay of the Japanese release is much faster. Control response is a lot better. This isn't just a game packaged in a smaller cartridge and released by a different publisher. This is a new revision of Dragon's Lair that is technically using superior hardware. NES cartridges have different configurations of chips inside. The often cited configuration contains two main chips, a program ROM and a character ROM. The program ROM contains the game code, and the character ROM contains the graphics. But what about other configurations? Some games don't have a character ROM. The US release of Dragon's Lair has a single 128K program ROM and 8K of video RAM. The game copies graphics out of the ROM and into VRAM as needed. The board is labeled UNROM, and this is a pretty early cartridge configuration that was used by many games. The Japanese and European releases of Dragon's Lair made use of the MMC3 chip, a mapper chip that provided some additional techniques and some flexibility to programmers. This time, the cart contained a second ROM for holding graphics. Dragon's Lair now had a 128K program ROM and a 128K character or graphics ROM. Are the technical aspects of Nintendo cartridges too much? No problem. If you've played these games before, you know the games using the MMC3 chip were released a bit later versus some of the UNROM examples and also have a bit more polish. In a previous video, we noted that Contra moved from a fancier cartridge on the Famicom to a simpler configuration for its international release outside of Japan. Contra removed features to work in a UNROM configuration. Dragon's Lair did the opposite and moved from the earlier UNROM to the fancier MMC3 configuration. It now had more flexibility for the programmers with its move to MMC3. And with this move, I have a few questions. What is the story on moving from UNROM to MMC3? Did the developers want MMC3 from the start, but it wasn't made available to them? Was the UNROM release a stopgap due to budget issues? The sluggishness of the US release is hard to miss. All of these questions are best left to interviews with the people involved in Dragon's Lair's production. Regardless of how they moved to MMC3, the change in cartridge configuration threw a bone to those of us interested in game code. Load any ROM up in a text program like Notepad, and it just looks like junk. That makes sense. It isn't a text file. It's full of machine code, numbers, and graphics data for the Nintendo to interpret. If a game had a 128K ROM available but only used 126K, maybe there is some padding in there for the 2K the developers didn't need. Maybe some zeros were used for padding, or maybe the unused space just held junk that wouldn't be referenced by game code. The Dragon's Lair ROMs for Japan and Europe have machine code just like any other game, but the unused areas are padded with unassembled source code. There is a lot of it. A lot of it. There is also some text that appears to be part of the development environment, MS-DOS perhaps. How did this happen? My guess is when they ran the assembler to take their source code, turn it into machine code, and create the ROM files for the game, they didn't specify the proper size. The assembler just pulled in whatever it saw to fill in the gaps. So the Japanese and European retail releases of Dragon's Lair ended up with game data, code, graphics, etc., as well as a lot of unused junk that turned out to be pretty interesting junk, in my opinion. I'd like to parse through some of this for you and make what I hope to be some reasonable assumptions, and I welcome your thoughts on it all. Let's start with, of all things, Nintendo Power. Volume 23 from April 1991 has a feature that covers developers of England. Page 47 provides some insight into developer Elite. At this point in time, Elite had developed many computer games and started to focus on console game development. Their development house, Motive Time, had completed 2 games by this point, Dragon's Lair for the NES and Dragon's Lair The Legend for Game Boy. So it would seem that Dragon's Lair NES was their first NES game. For those of you that have played Dragon's Lair before, you might be saying, and it shows. I'm not here to defend the final product, but I do think that we could use some perspective. In 1990, Famicom and NES development was as easy as purchasing a development box from Nintendo, loading up Visual Assembly 90 and selecting File New Nintendo Game, and then consulting StackOverflow.com for copy-paste solutions from the pros. Wait, no, that's not it. That's not actually how games were made. In the same issue of Nintendo Power, the first company mentioned is Rare. At the time, they had developed around 50 NES games. Right off the bat, the article mentioned that Rare's programmers created a development system for it. Today, we have photos of part of this development system. It looks like Rare used the RAM cart from a Famicom disk system as a cartridge port interface, ripped out the retail PCB, built some development interface hardware, and placed it in the shell. Obviously, there was some software involved on whatever machines they used to write their code and interface with this board, likely using this port up here. That's Rare, but what about Motive Time? Let's move to the ROM contents and try to piece together their development environment from any clues we can find. So it looks like Motive Time had their own in-house assembler to turn their assembly instructions into machine code. A few lines above this, you see M6502 with some hyphenated characters. This looks like a command line to me. M6502 is a partial name of an executable, possibly this Motive Time assembler. 6502 is the processor architecture used by the NES. The dashes with letters and numbers are parameters. It is assembling the file main.asm and outputting errors to dlair or dragonslair.err. That's my best guess, pretty typical syntax. If you look up a little ways from here, there are some environment variables with path info. One of the variables is BCASM with M6502. That's probably the full executable name from what we saw cut off in our first area. Some environment variables that start with B help, and B backup, for example, reference a path starting with C:\brief. We have evidence of an application called brief. Further down in the ROM is a bit more evidence. Okay, so Brief is a programmer's text editor, basic, reconfigurable, interactive editing facility, and was originally developed by Underwear Incorporated. If you haven't heard of Underwear Inc., well, it doesn't matter if you spell it correctly, don't use Google image search. Brief was sold to the software's publisher, Solution Systems, in 1990, and then sold to Borland a year later. Support was later integrated into various applications, such as Microsoft Visual Studio. A few lines down, we see another group of error messages that appear to also be associated with Brief, followed by some of my all-time favorite error messages, and another reference to a 6502 assembler. In one of the source code segments, there is an area that appears to send to MS-DOS and references a directory called PDS-MAST. Based on the subdirectories and file name, it looks like dlair FCS, Dragon's Lair Famicom, EEPROM, Erasable Programmable ROM, and DL.PDS. So working off the PDS lettering, I wondered if it stood for Programmer's Development System. As mentioned in an article on RetroReversing.com, PDS was a development kit for several 8-bit systems, including the Commodore 64 and the ZX Spectrum, among others. It was very popular in the UK. It would make sense that Motive Time, a company in England that developed software for several computer systems, would have invested in the PDS development kit prior to diving into NES development. What is a PDS development kit exactly? Well, software could be written on a PC and then transferred to a target system via an interface card in the PC. Ports on the back of the card would allow a cable to be connected from the development computer, where the code resides, to the target system, responsible for running the program. As mentioned earlier, Rare didn't have access to an NES development box, reverse engineered the Famicom, and made their own Nintendo PDS interface. Motive Time either reverse engineered the Famicom themselves or most likely purchased a license, schematic, development board or something from Rare. Perhaps from another third party, but probably from Rare. On the software side of PDS, we are lucky to have access to the PDS 6502 manual, thanks to websites like cpcwiki.eu. It spells out some of the pseudo opcodes developers can use in PDS, including send, which is what we saw in the Dragon's Lair ROM file. Sending to Computer 1 was most likely used for sending the assembled code to the Famicom. The MS-DOS line would seem to be used to write the assembled code to disk in a .pds file, a file potentially used later on as data to write to an EEPROM. Alright, so here are my assumptions based on what I've seen in the ROM. Again, this is mostly guesswork. Motive Time used at least an MS-DOS-based PC environment for development, as there are references to the application brief as well as some DOS environment variables. Based on a send pseudo opcode with a directory path, they used a PDS system for developing 6502 assembly to create NES and Famicom games. Programs were likely sent to a Famicom PDS interface similar, if not identical, to what Rare used. Motive Time also either developed their own 6502 assembler or had some sort of fancy batch file used to assemble ASM files. Then there is Dragon's Lair's move from UNROM to MMC3 between the US and Japanese releases. I'll have a go at this one too. The copyright on Rare's Famicom PDS hardware is 1988. I assume they had multiple revisions of this hardware as new chips were made available. The earliest MMC3 release is allegedly 8 Eyes in late September 1988. Perhaps Rare bought 8 Eyes or some other MMC3 game and used the chip to craft a new PDS interface. Motive Time could have purchased a PDS interface for the Famicom or NES, possibly used and slightly outdated, from Rare to allow them to develop NES games, starting with Dragon's Lair. An upgrade to an MMC3 capable dev board a bit later, also perhaps a hand-me-down from Rare, plus a bit more programming experience could have allowed them to improve the game's performance for the Japanese and European releases. Or maybe Motive Time started development of Dragon's Lair for UNROM outside of PDS using some other methods, but later acquired fancier development hardware between the US and Japanese releases, providing the programmers with a more convenient development environment and a way to tighten up the speed issues with the game. This is all wild speculation on Motive Time's development hardware and timeline that is purely based on some text found in the ROMs. Rare's custom hardware may very well have nothing to do with Motive Time's development environment. Regardless, we still have the source code itself. Here's some of the source code we found in the ROM files. Labels, variables, constants, and even comments help us understand it. Even if you don't know assembly code, you can just look at the comments and think, I'll bet this code has something to do with daggers. Call it a hunch. And based on the spelling used in these comments, we can verify that they were written by a real programmer. Below the comments are labels on the left side with no indentation. Under those labels and indented from the left side is assembly language. 6502 assembly in the case of the NES, and to the right of the assembly language are the operands, or parameters. These instructions are converted into machine code when this source code is run through an assembler. The machine code is accessed by the NES, emulators, etc. to run the game. Can we pair this source code with its assembled machine code counterpart elsewhere in the ROM, and pair that with disassembled code in the debugger for Dragon's Lair? Essentially, can we bring the code full circle? The best way to do this, in my opinion, is to assemble the source code by hand. How we get from this to this. Here are some assembly instructions. When code is assembled, these instructions, values, and RAM addresses are converted into numbers that the target machine's processor will understand. In the case of 6502 assembly, the opcode for DEX is CA, and the opcode for RTS is 60 hex. What about these LDA examples? One LDA loads the specified number into A. The second one loads a number from a 2-byte address into A. Both statements are LDA, but their parameters are different types. Because of this, their opcodes are different from one another, despite both being LDA. The codes tell the machine what to expect next. One has a single byte, a value to load into A. That opcode is A9. The next gets its value from a 2-byte RAM address to load into A. That opcode is AD. The 2 bytes are provided in order from low to high, so the pair appears backwards versus what we specified in our assembly instructions. There are 4 examples of what a programmer would write on the left next to the same code translated into something the Nintendo can understand on the right. When you view the code in a debugger in an emulator, some emulators have an option to view opcodes. Messen lets you place them to the left or even underneath the disassembled code. Back to our source code, we don't know the numbers that some of these variables are referencing, and you now know that some instructions have multiple opcodes. So, what's our approach? How do we find the numbers to search? I'm going to target this section here for search criteria. BEQ is opcode F0, an easy start. The DI-free label next to it tells the code how far ahead to branch. It wants to skip over a single byte, the byte that represents RTS, and land at DI_free, the label for this LDA statement. We skip just 1 byte for this branch to reach our target, so 1 goes next to F0. Our third byte comes from RTS and is 60 hex. We talked about RTS just a moment ago. 60 hex takes the third slot. That's 3 consecutive bytes to search for in the ROM. Let's try for 4. LDA is loading weapon type. Here is a list of LDA possibilities alongside opcodes. The parameters in our source code don't reference X or Y, so it can't be any of these. Let's take them away. It isn't a hard-coded value either. The 2 remaining possibilities look the same. When addressing a single byte address, 0 page, A5 is used. When referencing a 2-byte address, absolute addressing, AD is used. I'm fairly certain weapon type is stored outside of 0 page, so I'm going to guess AD is the opcode used for absolute addressing. So, this code snippet would assemble to F00160AD, 4 hex values. Let's use them for a search. This emulator has a memory tool with an option to view PRG ROM. If we search for this series of opcodes, we stumble upon the location of those opcodes in the assembled ROM. The Japanese release of Dragon's Lair we have loaded in the emulator right now. If we right-click on one of the bytes and create a breakpoint on this first instance, the debugger will halt as soon as the game performs the actions handled by this code. If our numbers are correct, it will stop as soon as I attempt to throw a dagger. Got it. Here's our pairing. Source code on the left, equivalent disassembled code on the right. Messen's debugger lets you add comments as well as labels. So instead of having code that wants to branch to an address, we could add a label to that address and the code will now branch to that label we just gave it. The code starts to become easier to follow. So one could use comments and labels to help debug Dragon's Lair if they so desired. Turn the disassembled code into something more human language friendly, relatively speaking. The emulator will continue to function as normal. It doesn't care about all these numbers that now have labels and comments applied. With the source code and disassembled code in hand, what might we change? This location controls gravity. Okay, well, let's modify the value and see what happens. Easy. Let's see what else is here. There is source code in both ROMs for cameo screens, art, that appears after completing a level, like this one, after completing the first screen and entering the castle in the European release. Completing the first screen in the Japanese version, however, does not show the cameo screen. They both have the source code for the screens. What happened? The Japanese version has an RTS to return from subroutine after the first couple of lines. This basically says, yeah, skip the rest of the stuff here, we don't need it. Why? Maybe Motive Time didn't consider it finished. Maybe they were doing some debugging, temporarily put code in to bypass the cameo screens and forgot to remove it before publishing. Changing the RTS to NOP, that is no operation, lets the Japanese release continue on through the cameo screen code that has been there all along. This is the Lizard King. We have a lot of source code for him. It looks like one of the first values set is his hit count. It is set to 8. Let's set it to 1. That was easy. We could make him a bit more difficult though. The extraneous data found in Dragon's Lair is quite interesting. It lets us not only see some of the source code used to create the game, but also gives us an idea of what the development platform may have been over 30 years ago. I hope you've enjoyed this bit of ROM archaeology. If you would like to see more videos that involve diving into the code of old games, check out some of the other videos on this channel. Thanks for watching.